To solve log equations, take a look at the equation that you have. In this one I see that we have multiple logs, and we also have a term that does not have a log at all. It's just the number 1. When that happens, you want to get all the logs over to one side of the equal sign. So using some addition here, I'm going to add a log base 12 of x plus 1 on both sides of our equal sign. These are not like terms, even though they look pretty similar. And the goal of that first step is to go through and get all the logs on one side of the equal sign, anything without a log on the other side. Then from there, you need to condense all of the logs down to just one log here on the left side. That's a 2-step process. The first thing you'd want to do is take a quick look and see if you have any coefficients in front of your log. See if there's a number multiplied by your log. There is no number in front of this log, just an invisible 1. Same here, there is no number in front of this log, just an invisible 1. If there were a number there, we would want to take that coefficient and write it as an exponent. After you do the first step of condensing, which we don't need to do in this one because we don't have any coefficients, then you're going to want to write this with one log. We have log base 12 of, and both of these logs are positive, so we're going to multiply these two together. Once you are down to just a single log on the left side, then we are going to exponentiate each side. We have a property that says if you have the base of an exponent, and in your exponent you have a log with the same base, all of this, each of the bases and the log, those will cancel each other out and you will just end up with x. So for this particular problem, I want to take both sides of my equal sign and I want to make the left and the right side into exponents. So in the next step, I'm going to have an exponent of log base 12 of x times x plus 1. And I'm going to have an exponent of 1 with an equal sign in between. These are now going to be our exponents, and I want to choose a base here. So this is going to be something raised to the first power on the right side. And I want to choose the proper base, and the base has to match the base of the log. So what I'm going to do is I'm going to write in a base of 12 on both sides. The right side is going to be 12 to the first power. The left side is going to be 12 raised to the log base 12 of x times x plus 1 power. And then using this property over here on the left side, the base of our exponent is 12, the base of our log is 12. Those cancel out, and we just end up with an x times an x plus 1 on the left side, and 12 to the first power, just 12 over on the right side. Now I have something that doesn't have logs in it. Then I should go through and solve. Using the distributive property here, I would have x squared plus x. And then subtracting 12 on both sides, I would get an x squared plus x minus 12. This is a quadratic. And whether I choose to factor to solve, if it's factorable, or the quadratic formula, I'm going to want 0 on this right side. This does look like it will probably be factorable. I just need to find two numbers that add to be 1 multiplied to be negative 12. Those two numbers are a positive 4 and a negative 3. And I can use the shortcut. So positive 4 and negative 3 are my two numbers. So the left side factors as an x plus 4 times an x minus 3. I now can break that into two separate equations and solve those to get my answers. Oops. So our two solutions are a negative 4 and a 3. At least those are possible solutions. In this step, when I exponentiated both sides, I need to remember anytime I do that step, I do need to take our final answer and plug them back in to make sure they work, because sometimes you end up with extraneous solutions. So I'm going to take -4 and 3, and I'm going to check both of those. Let me start by taking -4 and plugging that back in for the x's in the original. So I'm going to check and see if x really is equal to a -4 for this problem. I had log base 12 of x, so that's going to be log base 12 of a -4. That's equal to 1 minus log base 12 of -4 plus 1. And I want to see if that does check out or not. I already can see it's not going to check out because we can only do logs of positive numbers. We can't do log of 0 or a negative. But if you were going to do this on your calculator, you would either type in log base 12 of -4 if your calculator allows you to change the base, and you can type that in manually. If you can do that, you can type that in directly. Otherwise, what I need to type into my calculator, if I don't have the way of typing this in as log base 12, I need to use the change of base formula, which would give me log of -4 and log of 12 on the top and the bottom. Both of these are log base 10, and I do have a log button on my calculator that I can use for those. So I'm going to type in log of -4 divided by log of 12 to do the evaluation of log base 12 of -4. When I hit the enter button, I do end up with an error. So because I got an error when I typed that in, that means that for sure x is not equal to a -4. That was an extraneous solution that was introduced into the problem when I did this exponentiation step. Now I need to check and see if 3 is a solution. The answer to this problem is either going to be 3, or if this one doesn't work, no solutions. So I'm going to check and see if x is equal to 3. Again, I'm plugging that back up into the original function, so that's going to be log base 12 of 3 is equal to 1 minus log base 12 of 3 plus 1. I want to see if those things are actually equal to each other. So using my change of base formula again, I'm going to type this in as log of 3 divided by log of 12. And when I do that, I don't get an error. I do get a decimal over here on the left side. Log base 12 of 3 is approximately equal to 0.442 if I round that off to 3 decimal places. And then here on the other side of the equal sign, we have 1 minus log base 12 of 3 plus 1. So I'm going to do log of 3 plus 1. I could just type in 4 there too, that would be fine, divided by log of 12. When I do that, if you compare those two decimals, they are the exact same decimal. So that does verify that 3 is a solution. So for this problem, there is a single solution. Our only answer that worked was 3.